and share my screen. And so small amount of stuff for us to cover today. Again, it's the topic 5 SQL 2 folder. That Pagilla Homework 2 link is now added right here, so you can go to that if you haven't already. This example array folder is the last new material really for us to cover today. Probably won't take too long to do it, but if you want to follow along to get access to this on the terminal, just as long as you're inside the wherever you clone your repository, just doing a git pull command to update your repo should get you access to this folder here. Last update, last thing real quick, I'll summarize what we talked about with the SQL quiz is in the quiz practice 2.sql file. We made it to the, I'll make this a full screen thing here for a second. We made past all of the hard parts through the joining and in particular with all the weird syntactic sugar for the outer joins. And the very last things down here is just a right join is just a left join where the arguments are reversed. So everything's the same about a left join and a right join. The natural join just automatically selects columns for you. So it's vast majority of times you want the columns that share the same names. So it's common to use natural joins for that. Similar to the using syntax being syntactic sugar to share the same column. This, you don't even have to specify the column names. And then the last thing we were sort of talking about the differences between the what was it? The subqueries and left and outer joins in terms of power. And we said that every outer join can be written as a subquery. It's just syntactic sugar for these different special types of subqueries. There were 2 syntactic sugars that we had. This sort of most correct syntactic sugar, but least understandable one. And this special case syntactic sugar that was a little bit more understandable. So every outer join can be written as a subquery. But it turns out not every subquery can be written as a join in some way. And in particular, if your subqueries are somehow using count functions, then guaranteed can't, or somehow using aggregate functions, then you can't rewrite them as an outer join anyway. So for the purposes of the quiz, you just have to be able to interpret things. So it doesn't necessarily matter that one is more powerful than the other. But in practice, people prefer to write out the outer joins rather than the equivalent subquery, just to make it obvious that the problem is a little bit more constrained that way. And when we get to talking about the efficiency of different implementations, the outer joins can be implemented a little bit more efficiently than subqueries because more optimizations available. I don't know, not a lot of people here, but any questions about any of that? Okay. So then the new things, all the stuff that we've talked about, all the stuff on the quizzes is only related to the SQL standard in particular and not Postgres particular things. This example array folder is a Postgres specific concept that we will go over next. And it will also be related to efficiency considerations that we'll start talking a little bit about next week. In terms of references for this topic, if you want a written reference, if you scroll down to the bottom of our README file, this arrays section right here has a link to the postgrestutorial.com section on arrays, and you can get a written reference about everything that we're going to talk about. There's many different array functions, but the only one that we're going to care about for the purposes of this assignment is this unnest function right here. And so again, the array is not something you need for the quiz, only for the Pagilla homework. And the unnest function is the only one that you'll need for the Pagilla homework. Any questions about just the setup of where I'm at right here in this example array before I open it up and take a look at it? Okay. Then it's got Docker Compose stuff for us already. So Docker Compose up dash D. Docker PS, yeah, it's not running already. Okay, there it is, it's running. So it's the standard psql command to connect. And if I type \d, you can see the contents of here has 3 different tables, and those tables are all different than the tables that we've been looking at before. So the files here are all totally different. And then in the upper window up here, I'll be opening vim create tables.sql to look at the contents of the tables and what we've done with them. Another real quick Vim sort of tip, something I do a lot, is I open up the same file multiple times inside of Vim in 2 different tabs. So I'm going to go :tab E create tables.sql again, and you can see up here in the 2 tabs, it's the same file open in 2 different times. But one of the use cases of that is that each tab can be opened to a different location in the file. And so now if I press GT between these 2 tabs, it'll sort of save my space in one location, and it makes it easy to edit multiple locations in the same file. I'll do that so that we can, yeah, it jumps back and forth in exactly the same. Yeah. Question is, will the changes show up in the other one? And the answer is that yes, this, so Vim has a very complicated system internally of how it opens up files. Technically, what we have is what's called one buffer in Vim that is the create tables.sql buffer, and the buffer corresponds to like the actual like file under the hood. And then we have these tabs are actually called windows in Vim terminology, and we have 2 windows into the same buffer right here. And because they're going into the same buffer, edits in one are automatically instantly reflected in the other. So you don't have to like do that :E to refresh things every time. It's legitimately the same file opened at the same time. I don't think like VS Code or other IDEs have this sort of support in them, that if you can open 2 files, it treats them as 2 separate things. Good question. Any other questions so far? Okay. If we come back to this, so I'm going to go back and forth between these 2 tabs. There's sort of 2 sections in this file here. This first section is arrays, and the particular syntax in this table for an array is this square brackets right here. For those of you who've done the C programming language, this should be like evocative of what the array type looks like in the C programming language that Postgres and basically all database systems internally implemented in C, and the SQL standard being formalized in the 70s at the same time as the C standard. So this is just the standard syntax at the time for arrays. And this is how you like the type of an array. In order to actually specify a set of values in the array, then this is down here in the insert, one of the syntaxes. If we scroll down just a little bit more, you can see there's a handful of other syntaxes for arrays. So this one right here is another syntax. It's just a string where inside of the string you have curly braces, and then inside of the curly braces it's double quotation marks. So double quotation marks representing an actual value now instead of a column name right here. But this bland and soft would be the same as something like this, with this word being bland and this word being soft. So in this notation, it's single quotation marks. Down here, it's double quotation marks. Both of these 2 lines down here, equivalent ways of specifying an empty array that do that. Anytime you do this, you have to explicitly typecast it like that, or just the string with the curly braces like that. And then, yeah, the semantics of this is that, so it's like a Python list or any sort of collection object, that there's just 2 things here in this column instead of 1 thing. So the array lets you have multiple things in a column. questions? Make sense? The arrays is an example. Next week, we're going to see this word a lot, but it's an example of a denormalized representation of a database. And database theory people hate denormalized things. They like normalized things. And so there's below this array section, there's a normalized version of this database that has all the same information in it. In general, the difference between a normalized and a denormalized database is that a normalized database will have more tables, and you have to combine those tables together using joins somehow to get to the denormalized version. So I'll run some queries down here in a little bit to see how these two things are related. But down here under normalized, there's two tables instead of one table. And the second table is going to be capturing all the information in the array. There's no arrays in this normalized version, just ordinary types of integers and text. So down here, let's run some queries. Select star from food underscore array like this. And when, so this flavors column has all the information in the arrays. And you can see that for brevity's purposes, this is giving us, it's using the second syntax, the curly brace string syntax to demonstrate that this is an array, multiple values right here. And the only function that you need to use, that you'll want to use for any of these problems in Pagilla 2 is the unnest function. So real quick, I'm going to change this command from select star to explicitly list all the column names. So ID, comma, food, comma, flavors like this. And the unnest function applies to whichever column contains the array. And what it'll do is it'll separate out these things. So if I wanted to say, for example, find all of the food items that are sweet, I can't directly look inside of this flavors column right here to find this sweet thing. I have to use this unnest unnest function to extract that information. And I'll run this and then we'll talk about what it's doing. So you run unnest again on the array columns, hit enter, and it turns those columns into non-array columns. It turns it into just a traditional value. In this case, it's a text value because these are a text array right here. And what it does is it duplicates whatever the row is here, this banana row. It duplicates it once for each one of the values in the array. And so here we get the two banana rows, and then the sweet and the soft corresponding to the sweet and the soft up here. It's mostly intuitive that for these ones, how it works, celery has only crunchy because up here is only crunchy is celery. If you look at water or vitamin pills, those don't have any flavors associated with them. And so you can see after you apply the unnest function, the water and the vitamin pills are not listed anywhere in this results. So after applying the unnest, anytime you have an empty array, it's not going to expand it at all. That row will disappear. And so if we wanted to get all the foods that are sweet, then the query would look something like this from food array, where flavor equals sweet like that. Here I can't say where flavor equals sweet because I need to reference this particular column right here. We can try doing something like as flavor like this, and we hit enter, and you see that we get this column flavor does not exist, even though I've named it right here. In order to be able to access this column here, so there's a very common error right here, or a very common pattern right here. You are unnesting something and you want to do the where clause on the results. You can't just directly name the column like this and do the where clause on that column. Instead, you have to create a subquery and do the where clause on the subquery. Another good pattern inside of P-SQL is if you type \E in P-SQL, it'll open up a Vim window for you down here with whatever the previous query was that you were working on. So it's starting to get like a long query. We're doing a significant modification to it. I don't want to have to do that modification just in the P-SQL window. I want to use my good Vim editor to do that. So \E does that. And then as soon as you quit out of it, it runs that query for you. So \E, I'm going to make this whole thing right here a subquery. And again, we have to name that query. So T like that, and we'll select food from that query. Make it look a little bit nicer since we're in Vim, and why not? As from like that. So we have this subquery right here that we're selecting from, and only selecting the food column right here. I named this unnest column to be flavor, so now we can reference it right here as flavor equals sweet. Escape, save that, and there's my results. Food is banana and carrot. Those are the sweet things. Nothing else is sweet. Any questions? Okay, so that's it for me talking today. And you're welcome to stick around and work, ask questions as you work, or brave the rain, or wait till the rain stops and then head off somewhere.